Welcome to session 4 of Oracle SQL, that is Oracle Paper 1 SQL part. This session we are going to see about displaying data from multiple tables. This session aims to cover how to obtain data from more than one table. The objectives which will be covered in this session are: write select statements to access data from more than one table using equality and non-equality joins, view data that generally does not meet a join condition by using outer joins, and join a table to itself by using a self join. Let's come to obtaining data from multiple tables. Sometimes you need to use data from more than one table. In this slide example, the report displays data from two separate tables. Employee IDs exist in employee table. Department IDs exist in both employees and department tables. Location ID exists in departments table. To produce the report, you need to link the employees and departments table and access data from both of them. Let's see what is the use of Cartesian product. When a join condition is invalid or omitted completely, the result is a Cartesian product in which all combinations of rows are displayed. All rows in the first table are joined to all rows in the second table. A Cartesian product tends to generate a large number of rows and the result is rarely useful. You should always include a valid join condition in a where clause unless you have a specific need to combine all rows from all tables. Cartesian products are useful for some tests when you need to generate a large number of rows to stimulate a reasonable amount of data. Let's move ahead. Generating a Cartesian product. A Cartesian product is generated if a join condition is omitted. The example on the slide displays employee last name and department name from the employees and department tables. Because no where clause has been specified, all rows, that is 20 rows from employee table, are joined with all rows, that is 8 rows in department tables, thereby generating 160 rows in the output. The query used in this case is select last underscore name, comma, department underscore name as DEPT name from employees, comma, departments. We have not used here where clause. That is the reason we have got the output as Cartesian product. Let's come to different types of joins supported by Oracle 9i database. The Oracle 9i database offers join syntax that is SQL 1999 compliant. Prior to 9i release, the join syntax was different from ANSI standards. The new SQL 1999 compliant join syntax does not offer any performance benefit over the Oracle proprietary join syntax that existed in the prior release. So, in Oracle proprietary joins, in 8i and prior, we had equi-joins, non-equi joins, outer joins, and self-join. In SQL 1999 compliant joins, we have cross joins, natural joins, using clause, full or two-sided outer joins, arbitrary join conditions for outer joins. Let's come to joining tables using Oracle syntax. We come to defining joins. When data from more than one table in the database is required, a join condition is used. Rows in one table can be joined to rows in another table according to common values existing in corresponding columns, that is, usually primary and foreign key columns. To display data from two or more related tables, write a simple join condition in the where clause. The syntax is table1.column denotes the table and column from which data is retrieved. Table1.column1 equals to is the condition that joins or relates the tables together. Guidelines: when writing a select statement that joins tables, precede the column name with a table name for clarity and to enhance database access. If the same column name appears in more than one table, the column name must be prefixed with the table name. To join n tables together, you need a minimum of n-1 join condition. For example, to join 4 tables, a minimum of 3 join conditions are required. This rule may not apply if your tables has a concatenated primary key in which more than one column is required to uniquely identify each row. Move ahead, we come to what is an equi-join. To determine an employee's department name, you compare the values in department ID column in the employees table with department ID values in departments table. The relationship between employees and department tables is an equi-join. That is, values in department ID column of both tables must be equal. Frequently, this type of join involves primary and foreign key complement. Equi-joins are also called simple joins or inner joins. Let's move ahead. We come to retrieving records with equi-join. In the slide example, the select clause specifies the column names to retrieve: employee's last name, employee number, and department number, which are columns in employees table, department number, department name, and location ID, which are columns in departments table. The from clause specifies the two tables that the database must access: employees table, departments table. The where clause specifies how the tables are to be joined. That is, employees.department ID equals department.department ID. Because the department ID column is common in both the tables, it must be prefixed by table name to avoid ambiguity in records. We come to additional search conditions using an AND operator. In addition to the join, you may have criteria for your where clause to restrict the rows under consideration for one or more tables in the join. For example, to display employee Matto's department number and department name, you need an additional condition in the where clause. So the syntax would be select last underscore name, comma, employees dot department ID, comma, department name from employees, comma, departments, where employees dot department ID equals departments dot department ID, and last underscore name equals Mattos. So only the employee whose last name is Mattos and the department IDs of both the tables are same, that record only would be displayed in the select statement.